So I'm Bruce Wallace. I work in the Strategic Technology Office of DARPA. The Strategic Technology Office executes system-level programs. There's a number of offices in DARPA. Some work on basic physics, materials, sciences. There's a lot of effort in biotechnology now, brain studies, things that help the soldier. Electronics, fundamental electronics work and all. I work at a higher level where we try to take some of the more basic fundamental capabilities developed in DARPA and integrate them into a package to give the warfighter an improved capability. Because what we try to do in DARPA is either avoid surprises or create surprises, whichever leads to our advantage. All are defense related, but we do have a lot of commercial spin-off. DARPA is a composition of a lot of entrepreneurs who have sound technical capabilities, and they try to create new ideas and programs and integrate teams from across the country, be they university or industry, to put together the best team to try to solve these things and present a capability for the government. We gravitate more towards the engineering. As I said, we build ourselves on a lot of the technology that comes out of some of the more fundamental offices. You know, we have the groups who are working on bending light over mountains, if you will, making people leaping over, crawling up the sides of buildings, a lot of fundamental materials work. A lot of the work done out here at the exhibition actually originated in DARPA funding, trying to create components that people couldn't imagine before. In the systems offices, we do other things. Examples are a lot of the aircraft studies that we work on are challenging engineering problems that had to wait for the technology to come along. And once the technology did come along, it was recognized that it was available now, and we could start looking at new things to do. Example, one of my radar systems was not possible to build 5 years ago, but we had a terahertz electronics program in our microsystems technology office that developed components to a sufficient level that I could, in my program, integrate them into receivers and radar systems to build the system that I wanted to achieve. So sometimes it's a matter of waiting until the more fundamentals work is done. So I fundamentally work on systems associated with millimeter-wave technology. That's what I've done throughout my career. I originally started in the Army, retired from the Army, and then went to work for DARPA. Working on millimeter-wave sensors. So I have a number of programs all associated with that, primarily trying to do battle with the problems of degraded visual environments, either dust storms or helicopters landing in dust and people getting injured, or landing in snow and getting injured because the pilots can't see, or even engaging targets through clouds or being able to penetrate clouds so that we can support our troops on the ground. So that was the advantage of the systems I work on. They're basically imaging systems. Significant challenges in creating these systems. We're creating radars that have never existed before at frequencies that people haven't operated at before, 95 and 235 gigahertz, insane frequencies by some people. Most radars are significantly lower frequencies than that. So it's very exciting. It offers a lot of great challenges from a technical standpoint. It's hard to imagine being a high-risk organization like DARPA and always being successful. The two don't really go together. We do tend to talk a lot about our successes, and sometimes our programs are so out in the world to see that the failures are really spectacular, if you will. We really hope that even when we have failures, we learn a lot that will advance the state of the art. I fundamentally feel somebody has to be losing sleep on a DARPA program, and it has to scare you. And if it doesn't scare you, then it's not appropriately risky.